Hello everyone, welcome back to my channel. In this video we are going to learn two-way ANOVA. In the previous video we tried to check the effect of one variable on the other, that is trying to predict the performance differences. For example, we try to predict performance differences between males and females, which happens to be gender on performance. So in that case we can use t-test to check whether there is differences in performance between males and females, and this one is just only for gender. It can be used for only one variable and not more than one. And then another thing too, ANOVA can also be used to compare the levels that are more than 2 on only one categorical variable. And for example, we have academic level, and the academic level could be undergrad, master's, PhD. So that one we can use ANOVA, and it is only used on only one particular variable. But what if we try to use these two together? Maybe we want to find out the performance differences between gender or male and female who are undergrad or who are masters. That is where the two-way ANOVA comes in. So two-way ANOVA is nothing than comparing two categorical variables, their effect on a continuous variable. So the dependent variable must be a continuous variable. For example, the exam score must be continuous. It should be in the form, when we say continuous, it should be in the form of a number. So it shouldn't be in other factors or other levels. It should be in the form of a number. Now, when do researchers use two-way ANOVA? Researchers use two-way ANOVA when they want to study the effect of two categorical independent variables. So the categorical variables are independent on one continuous dependent variable. The continuous variable must depend on these ones. So for example, we want to predict the exam score, and then based on these are the two categorical variables, gender and then academic level. So these ones are independent, and then this becomes dependent. So in real world situation where we use this one, we have education, investigate students' performance based on gender, and the gender could be male and then female. So these are the levels. And then academic level, we have undergrad, masters, and then the outcome is just about their scores, how they perform. The performance is about their scores. It can also be applied to healthcare to investigate patients' recovery rate based on treatment type and then the gender. So we check the treatment type A for both males and the females, treatment type B for both males and the females, to see the recovery rate or the recovery score. And then in business too, we can just investigate employees' productivity based on department and then training method, and that applies to agriculture. You can check it yourself. In two-way ANOVA, or in every statistical test, they have their questions. The same applies to two-way ANOVA. Two-way ANOVA have three main questions. It has three main questions. The first question is the main effect. It has two main effect questions and then one interaction question. So for example, if our research is about predicting the team score both based on the fields they play their matches. For example, we have Barcelona and then Real Madrid. So they becomes our teams, team A and then team B. Team A is Barca and then team B is Real Madrid. So the first main effect is we check score differences, whether there is differences in scores based on the team, or whether the scoring of the teams differ. That is one main effect. So does team affect goal scoring? So that is the question. And then the other one too, does goal scoring depends on the field that they play the match? Maybe on field A, there are 4 goals that has appeared on that field. Field A we have 4 goals. Field B we have 5 goals. do we have goals differences based on the field they play the match. And then the interaction is just about trying to use each and every one of the team and then match it on the field they play the match. So team A and then team B, what are their scores in field A? Team A and then team B, what are their scores in field B? So example, we have, does the effect of team on goal scoring change depending on the field? So if their goal score for team A, if the score of team A and then team B, do they change when you move them from one field to another? So this one, we are taking this team and at the same time we are taking field. So we measure them on field A and then we measure their scores on field B. So that is where the interaction effect comes in. So to get it clearly, let's take some examples here. So on we have our teams, team A and then team B, and we also have our fields, field A and then field B. So the main effect comes in, we take the main score, so average score of team A and then average score of team B to check whether there is differences in their scores. That is one main effect. And then the second main effect, we take the goal score, mean goal score for team field A, mean goal score for field B, and then compare them to check whether there is differences or statistical significance differences. And then we come to the interaction. So the interaction, we match each and every one of the teams based on, so we have team A, team B, and we have, they are playing within based on the various fields. And then on field A, team A score 5 and team B scored 3, the difference is 2. And then field B, team A scored 5 and then team B scored 4, the difference is 1. We say there is no interaction when the score did not change from one field, or the scores of the team did not change from one field to another. For example, on field A, team A scored 6 on both fields. On field A and then field B, it maintains its scoring rate for both fields. Team B maintains its scoring rate for both fields. So that means there is no interaction effect here. So there is only interaction effect when the scores of teams changes based on the field. So for example, team A score high on field A and then low on field B. Team B scored low on field A and then high on field B. And that is the concept of the interaction effects. And then we have some assumptions that we check whenever we are performing our two-way ANOVA. We have to make sure that the dependent variable is continuous. So for example, exam score, blood pressure, income, it should be continuous. It should be in the form of a number. The two categorical variables, so the independent variables must be categorical. So for example, gender, it should have categories. You belong to the male category or female category. Academic level, you belong to whether you are undergrad, masters or PhD. So there should be different groups or categories, and no one should be from this group and at the same time the other group. There shouldn't be intersection. One person cannot be a male and at the same time a female. No. And then we also have independent observations. So what you observe from this person shouldn't depend on the other person. Maybe you've taken Akosia, the first person. You observe that her performance was this. And the performance of Akosia shouldn't depend on the performance of David. And the performance of David shouldn't depend on the performance of the other person. So that is what we call independence of observations. So these ones, we just use our eyes to check them. So the continuous variable, we have to make sure that it's in the form of a number. This one should be categorical. We should make sure that these ones are independent. But the normality and the homogeneity of variance, these ones are being done whenever we are performing the experiment. The normalities here is just trying to check the continuous variable, that is the dependent variable. it should assume that it should be approximately normal. And then if you do not understand the normality check, you have to check my normality video. So we have to make sure that the independent or the scores are being normally distributed. It shouldn't veer to one side. And then we also have homogeneity of variance. When we say homogeneity of variance, we take the two categories and then we check their variances should be approximately equal. So for example, the score of males, so we check the score of the males, then we check the variance score of, so we take the variance score of males and then the variance score of females. So they should be approximately the same. And then note one important thing is, if these assumptions, especially not all of them, if these assumptions are being violated, then your two-way ANOVA results may not be accurate. And we also have some statistical tests that are being used. And then the main statistical tests, we have Shapiro-Wilk test, which is used for the normality test, and already you understand the normality. And then the leveling test is also used to test the homogeneity of variance. And then we also have the F test for the effects. So the F test is used to check the two main effects and the interaction of effects. And now check something that is very important here. In the decision rule, whenever you are going to take decision, the data can only be normally distributed when the p-value is greater than 0.05. And there will be homogeneity of variance when the p-value is greater than 0.05. So you will notice that for the homogeneity of variance and then the normality test, the p-value must be greater. For these assumptions should be satisfied, these two assumptions or these two tests should qualify. The p-value must always be greater. But when we come to the effect side, the p-value must be less than 0.05. So this is what you have to take notice of. So in conclusion, in two-way ANOVA, we try to use two categorical variables to check their influence on one dependent continuous variable. So we will do it better when in our next video. That is where we try to run the experiment in SPSS. So just continue to watch and then you understand it better. Thank you.